Hello again, Math 1. We're back for another lesson. This is going to be a review of basic GCF factoring and factoring by grouping. There were some things I saw on day 134 that kind of concerned me, so I want to go over those concerns. And hopefully you guys, again, it's just going to be a 6-problem assignment, can make those error corrections, and we can move forward. So, this is all about what did we do when it said to factor, but it didn't have like 4 terms and it didn't say anything about factoring by grouping. Well, your job back then was just to basically find the greatest common factor and then create a GCF times a group of leftovers. We use prime factorization, so I'm just going to demonstrate that again here. .42 can be broken up into, in fact, how about I just come over here? 42 is 2 times 21. And then 21 is 3 times 7. So you got 2, 3, 7. But we always included a 1, just in case 1 was the only thing that they shared. And if it's a negative, I'm going to include a negative 1 as well. Also, keep the variables, okay? Make sure you expand them on the tail end. So then you got 63. It doesn't divide 2, but it does divide 3. And it's 3 times 21, which is 3 times 7. So you've got, again, another negative term. So I'm going to go negative 1 times 3 times 7. And then x triple y. All right, 21's a piece of cake because we've already seen it broken down twice here. And hopefully you guys can see that, hey, it divides 21 here. Hey, it divides 21 here. Our third term's 21. Seems like the GCF's going to be, at least in the number portion, 21. But if we're going to go through it the prime factorization route, 3 times 7 is going to be 21 with a 1. X, y, y. All right, so if you've totally forgotten about how to do prime factorization, there it is. Now the GCF is what they all share. So they all share a 3, and they all share a 7. They all share an x, and they all share a y. So here's how we do this. We say this polynomial can be written as its greatest common factor, which in this case is 3 times 7 times x times y. Notice I'm not saying it's 3 times 3 times 3, 7 times 7 times 7. It's just what they all share. So it's 21xy. And then your leftovers. In this case, it's 3 separate place-holding terms. All right, so there should be 3 different parts in there. The first part is negative 2xy. The second part is negative 1 times 3, so negative 3 yy, or y squared. And then our last one is plus 1y, or just plus y. All right, so that's how you successfully factor a 3-term polynomial so far. That's not the only way in which we could determine the GCF, though. I showed you guys a shortcut, which I'm going to review here on number 2. So in number 2, this is kind of just like the eyeball method. What I mean by that is you just eyeball it, you check it out, and you say, what do they share? And try to do the GCF kind of mentally, okay? So I'll write this a little bit bigger so you guys can see it better. And this is by far, I think, the quicker method, all right? The better mental math you have, the quicker things are with factoring. So then when I look at 4, 28, and 16, 4 really jumps out to me as the number that all 3 of those factors divide. So the GCF, I'm instantly determining what that is kind of on the fly. It's like I know 4 is what they all share. So 4 is going to be a part of the GCF. And in order to determine the leftovers, I'm going to start dividing each term by the part of the GCF to figure out what those leftovers are. So I'm dividing by 4, dividing by 4, dividing by 4. Great. Now let's just do it one variable at a time. I have x, x to the third, and x squared. So the thing that they all share is in x. But the question is, what power of x? Well, it's always the smallest power that they all divide. So it's like if this is only 1x here, I can't just randomly say that, oh, the GCF is x squared. No. X is all 3 of them, is all that the 3 of them divide. All right, and then we talk about y to the third, y to the third, and y to the third. It's y to the third. Okay, now that's your greatest common factor. The leftovers are the quotients of these three pieces. So when you take 4xy cubed divided by itself, you get 1, because anything divided by itself is 1. When you take 28 divided by 4, you get positive 7. X cubed over x is just going to be x squared. The y cubes cancel each other out completely. And then you have negative 16 divided by 4 is minus 4. X squared over x is just going to be x. And again, the y cubes here are going to cancel out completely, leaving no more y's inside the group. All right, so that's the alternate way of factoring where you don't have to actually do prime factorization. Now, getting to the heart of the matter, factoring by grouping. I have some issues. On the last video, I told you guys about needing to rewrite polynomials to make them factorable when you do factor by grouping. I also talked about on the last step, at times you guys need to look for a GCF that needs to be taken out. So, first part of error correction. Are you rearranging or rewriting the polynomials? Because I checked out the homework of what people turned in already from day 134, and a lot of you guys weren't doing it. Now when you see this, 9x squared minus 2y squared plus 9xy minus 2xy. I'm hoping that the 9x squared here and the 9xy are jumping out at you. It's like, hey, the 9s should go together, plus they share an x. So I'm going to rewrite this. It's going to be 9x squared plus 9xy. And then it seems like the negative 2y squared should just be flipped around like that. Okay, so yes, in this term, you had to rearrange, otherwise it would factor to gibberish. It wouldn't make any sense at all. So now what we do is we say, check these two out. What do they both divide? Clearly a 9. Okay, so you're going to divide both parts by 9, and they also both carry an x. Okay, so our GCF is 9x. The leftovers are 9x squared divided by 9x, which is just x. 9xy divided by 9x is just y. Okay? And then you move over to here. And remember, keep in mind, you want your leftovers to be identical. We should get basically x plus y in the second one. So here, it appears that negative 2 is the obvious numerical GCF. They both carry a y. All right, so in order to determine the leftovers, divide by negative 2y. So the negative 2 divided by negative 2 is plus 1, and then y squared over y is just y. So negative 2 divided by negative 2 is 1. Y divided by y is 1, and then the x is just left there. Now, sometimes students can get a little bit confusing when they see a result like this. X plus y does not look identical to 1y plus 1x. But 1y plus 1x, if I use the commutative property, is 1x plus 1y. And the one coefficient is technically not necessary to define what x is or define what y is. So it is the same thing. In fact, I can just kind of erase what's in here and say, you know, looking over there, that's x plus y. And I think that clarifies it for you. Because if you get the basics of factoring by grouping, there are your leftovers. Here are your two GCFs. The GCFs create a binomial. That's a two-term polynomial, which is one of the factored pieces. And then x plus y creates the second one. And that's it. Let's check out number 4 now. So the first question of rearranging, maybe it would be a good idea in this case. I see a 9xz here and a 9yz here. Seems like the 9z's should be together. So I'm just going to rearrange right away. 9xz is going to be combined with plus 9yz. And then you have negative 15x minus 15y. So then with this group right here, I don't know if 9z and 9z seem kind of like the obvious thing right here. So I'm just going to go for it. 9z is the GCF. When you divide by 9z and divide by 9z, you get these cancel. X is all that's left. These cancel. Y is all that's left. For the second group here, minus 15 is what they both share. So that's my GCF. If I divide both parts by negative 15, those negative 15s just completely cancel out. So I'm left with a positive x, because the minus portion also canceled out. Negative 15 divided by negative 15 is positive 1, so it's positive 1x. Again, though, I'm just going to write x. And same thing over here, it's just going to be plus y. Negative 15 divided by negative 15 is positive 1. The GCFs create a binomial factor, and then your leftovers are here. This is what a lot of you guys were missing. Here's the error I want you to correct. Look at this, 9z and negative 15. 3 goes into both 9 and 15. Therefore, I can take this polynomial, factor it one more time. This little binomial, put a 3 GCF, and then you divide, you get 3z minus 5. So make adjustments, please.